Hey folks, this is Sung speaking here, and I'm going to give a demo of bringing the experience and the ergonomics I love feeling in dbt-utils during my time working there to SQLMesh natively, and just the story that kind of inspired that journey in the first place. But I think the best place to start is understanding what problem I'm solving for and why it matters to you. During my time at dbt Labs and even before that, there's something really cool about dbt that wasn't necessarily about its technical marvel. It was more about, it just felt like really empathetic and really ergonomic to solve some really basic problems that I really cared about. For example, dbt-utils is the reason why I had something easy to reach for as a utility when I could generate a surrogate key like this, right? And so instead of having to create a bunch of logic that, Googling up the hash function in order to create a unique ID in the first place, I just plug and chug some parameters for the columns I care about, determining what creates a unique key, and just moving on with my life, right? Because then dbt would compile the SQL behind the scenes to make something happen, and everything just works as expected. And I just trusted that they tested the logic behind the scenes, so I didn't have to test it myself and babysit that for the rest of my, job. Someone I really respect, Alex Butler, contributed some macros that look and feel like this. Things like generate surrogate key and pivot, which I know for those that are in the know are probably some of your best friends when it comes to dbt utilities, and brought kind of that same experience to SQLMesh natively, which is really cool. And so instead of having to write a bunch of SQL like this by hand, in SQLMesh, I could just get to plug and chug, some parameters very similar to what you saw here and move on with my life. And what's really cool is if you are not a fan of Jinja, that's okay, because behind the scenes, what's powering this is Python logic that's making this macro work in the first place to generate all the SQL, all right? And so in that story, I just presumed things like date spine and deduplicate must already be living and breathing in SQLMesh today, right? Because I was pretty impatient when I was just candidly, testing out some functionality within SQLMesh, but I realized it didn't work, right? And it's just one of those things where it's just there's a temptation to just kind of cross my arms or sit in my hands and go I'm gonna wait for the world to change for me. But I was realizing I have enough taste and context and skill to build the world that I want to see. And that same feeling, that same sense of ergonomic delight that I felt using dbt-utils, I want you all to feel when you're using SQLMesh every day. And so this video is really about that. But let's just focus on date spine, right? It's really around a couple things here, where you're going to see something that looks and feels like this, right? You usually have a dedicated SQL model within dbt that's creating some dates here, right? For the sake of this argument, and just to prove that I'm not pre-canning this demo too much, I'm going to do something like this, where I just change some of these states and just see how that looks and feels on the fly. And so when I build this out, I only want to build that specific model, right? And I want to see that living and breathing today. And the reason I'm doing this is just to see overall just the look and feel of using this, right? It takes a couple of time. It says, hey, I created a bunch of rows. It took 6+ seconds in order to make happen, right? From there, I'm hey, I want to understand how the sausage is made. And so I'm going to run a compile command so I can actually see the SQL rendered in my terminal. And let's say I just want to copy and paste this, and I want to run this in my query engine. And right now I'm just using BigQuery as a simple example, but I'm going to overwrite what I had there. And let's just see what happens. From here, I see a bunch of results. Yep, this is what I expect it to look like, days over time, and keep in mind, notice hey, why does this, for those that aren't familiar with date spine, the problem that this solves for is there are certain cases where the same where filter that you're using to kind of dictate a time range of certain dates, you don't want to have to copy and paste that over time across multiple models. For a simple example is sales promotion dates, where at the beginning of the week, you want to make sure sales numbers match a certain pattern that you expect to see in kind of their transaction data matched with very specific dates, right? And instead of babysitting those dates across the multiple models, you just join against that table, against the date column in your sales table, and just move on with your day, right? And so you notice here a couple things that are going on that are making this experience come alive, at least in the dbt context, is a couple things. One, it's using it's generating a bunch of things using, the power function, is doing a bunch of cross joins, things that really aren't that intuitive. If you're looking and trying to debug this for the first time, and it looks like it's manually doing this, it looks like, let's see here. Yeah, and then it just takes that CT, makes another CT over here, and adds dates to this column over time using window functions, and then just selecting less than or equal to the end date that I have, and just selecting from that. Cool. It's, not that intuitive to understand what's going on, but intuitive to understand the output that it's creating. So that's pretty easy from there. From there, I notice here, it's it took 2 seconds, but in the BigQuery context, I was charged for 2 minutes of time. Okay, cool. Not that big a deal for me, right? Especially if I'm living in dbt reality. Now let's compare and contrast that to my SQLMesh experience over here. And so over here, I have another model dedicated to date spine. Over here, I'm just doing a simple, CT and selecting from that. I've already created this, and so when I try, actually, you know what? I'm gonna do the same thing over here. I'm gonna do this. I'm gonna do this. Whoops. And then I'm gonna run a SQLMesh plan. And this is gonna create a dev environment to register my changes in the first place. And what it's saying is hey Sung, you are updating the parameters for this date spine macro that you created, and that's going to be breaking change. So you basically have to, refresh it or backfill it. That's going to create a table. Right now, it's just checking behind the scenes, making sure we can do this. It's evaluating it, bam. And it worked pretty great from there. Cool. And very similar exercise, hey, I want to understand how the sausage is made. And so, and instead of compile, I use the render command over here. And when I run this, I get something that looks very different. And this is intentional, right? Because you notice in the date spine example created by dbt, it was doing a lot of cross joins and a lot of convoluted logic, and they probably do that to make sure it works, in a similar way across all these query engines. But this query engine, this specific rendering is very specific to BigQuery by design. And the reason for that is you get a huge performance gain. And two, it's a lot easier to understand what the heck is going on with this query in the first place. And so for example, let's just say I want to run this manually just to make sure it's doing exactly what I expect it to do. I'm just going to run it like this, and bam, I get my data intervals. And I notice just a nice little quality of life change where it doesn't, generically append that timestamp 000 data that I probably don't care about, and it's causing extra storage. And from there, what's really powerful about this, more than just the ease of debugging, understanding what's going on, two is it takes milliseconds to run, and you're only charged for those milliseconds, right? And I know in the context of querying large amounts of data, this might not matter, but if this is something invoked across thousands of data engineers, it just feels so deliciously rewarding to know that something that used to take seconds in your dbt worldview, you get to now think of in milliseconds in your SQLMesh worldview. And even just little performance tweaks like this, it was worth hours of my time, so you could only think about this in milliseconds. And that's something that I take a lot of great joy in. And so what's really interesting about this is this same logic will transpile appropriately to the query engine of choice. So for example, versus in a dbt context, I'd have to install different adapters over time, and update my profiles to see hey, I'm noticing more and more a trend of people have multiple data warehouses in their company, such as BigQuery, Snowflake, and Databricks that all kind of coexist together. And instead of having to test this across different things and making sure it works exactly the same as you expect, what's really cool is in the SQLMesh worldview, you kind of get to have your cake and eat it too. So let's say, for example, I want to, make sure that this is going to work exactly like I expect in Snowflake. I can test that on the fly in real time and see, hey, how exactly will the Snowflake SQL look compared to the BigQuery one? This is it, because it's going to use Snowflake specific functions that are going to try and squeeze performance as much as possible, right? Because I want to make sure you get to think in milliseconds as normal as much as possible. Same thing when it comes to Databricks. You're going to see some cool stuff, right? you're going to see that, right? Instead of, in this case, unnest and generate array, it's going to do explode and sequence. And all of this is happening on the fly without having to point to hard-coded adapters that are creating their own kind of implementation details, because we're using SQLglot under the hood, right? And so that brings me to my next point of hey, how exactly is this macro built? It's not built using Jinja, baby. It's built using Python, and SQLglot, the things that you probably already know and love, as a data engineer. And what's really cool about this, and I'm gonna just walk through this step by step in plain terms, so there's no guessing games as to what exactly is going on. Is step one, when you're calling this macro, here, let me just do a quick reference point. So when you're calling this macro, what you're actually doing is you call it, you pass in the time kind of grain that you want, whether it's day, week, month, quarter, year, the actual dates and scope, and you can just use plain strings. What that will do is it'll pass it to this Python function over here. And what it's going to do is it's going to understand what's happening behind the scenes, where it's hey, you're bringing in a SQL expression. We're going to take that into account. And from there, you're going to have some validation checks that make sure that, no funny business is going on before we actually, render the SQL, right? And so you're getting some cost savings up front to make sure that this is working correctly before actually having to send this to your query engine and spend money there just to figure out something's wrong, right? And so from there, we validate and normalize some of the variables over here. We make sure that things like minute or seconds aren't included in this date spine, because usually the lowest grain of detail is day, all the way up to the highest grain is year. From there, we normalize the date times even further, and we actually have some extra error handling over here. That's just hey, if this doesn't work as expected, you'll get invalid formats and things like that. And so, for example, I'm going to do one for, some of the date math error handling that we have here. So let's say this is 2025. If I try and run this, it should error out as I expect. And it'll say hey, Sung, this messed up, invalid date range. You got to fix that, right? Something really plain terms, and it works pretty fast because using Python behind the scenes to go hey, this is how you fix it because this math ain't math, right? So from there, I'm gonna go back to this logic. From there, we cast it as date, and so instead of having to cast that manually, like you have to do in a dbt context over here, let me actually go back to date spine, all right? You just get to plug and chug dates in a vanilla way. So it's just less typing you have to do. That's really tedious and not really value add to do in the first place. And so that's one enhancement I intentionally made, because I know I was always annoyed at that when I had to write dbt date spines even by hand, right? Because I'm a pretty lazy person. And so from there, you'll notice here there's some conditional logic for quarter, because these engines, whether it's Spark, Databricks, or Postgres, don't handle that natively like some of the others do. And so, we make sure that we do some manual math for that and just say, hey, multiply months by 3 in order to create that date spine appropriately. From there, we use the generate data array function. And keep in mind, this is very specific to BigQuery. I believe most other engines don't have this, but what's really cool is I don't have to care about that, because I'm using SQLglot to implement this functionality. What it'll understand is behind the scenes is hey, when you say generate data array in BigQuery, what I understand is what you really mean is sequence in Databricks. What you really mean is recursion in Redshift, because they don't have a generate series type kind of SQL function. What you really mean is, right, et cetera, et cetera. And so that's what's really cool about this. Even with a simple function call, a lot of the complexity is abstracted away from me, because SQL under the hood is powering this experience. And a huge shout out to George Sitas for making that happen, because that was definitely the hardest part of contributing to this. It's just making sure SQLglot behind the scenes was doing what I wanted to do, right? From there, instead of just returning an array, or just an array result, it kind of looks and feels like a dictionary, right? I explode that out so it actually turns into the rows that I care about, and I return a select statement. And the reason why we use SQLglot, because understandably, you may think wait, why can't I just use string substitution and SQLglot can work under the hood anyways? Well, when you use SQLglot, we make it much more deterministic, right? The same inputs will always get the same outputs, because we're creating an abstract syntax tree, or AST, right? And I'll put a link in the description for a primer on that, so you can understand and appreciate the depth and breadth of what that does. But essentially, just make sure that hey, when I am running this in a SQLMesh context, that when I'm running this in Redshift, SQLMesh will understand behind the scenes, like, hey, we know Redshift doesn't have native kind of generate series or generate data array type functions. Therefore, when we transpile it on the fly, even though you're using BigQuery as your engine, hey, for your spot checking, we'll make sure that when this is pointed to Redshift, this exact query will run. And you have peace of mind that you don't have to juggle different adapter implementations or talk to random community members that are maintaining those adapters to figure out like what's going on when you're debugging. You just get to know vanilla Python that you know and love with a library that's battle tested in production to just like quality of life ergonomics of just like performance in milliseconds and just like error handling and not having to cast it manually even while you're using the macro. Like, these are all things that I'm really excited for you to use, right? Because it's not that it's like some huge technical marvel of like, ooh, like this feels like rocket science. It's just like, no, like something that used to take 5 to 10 minutes of like boring, tedious, non-value add typing, I just get to turn into a couple seconds experience and move on with my working day. And that's really my goal in making this work, because the hardest part of data engineering is not building data pipelines, it's maintaining them over time. It's trying to not reinvent the wheel as much as possible, because a lot of us has probably written the same SQL a million times over, right? And you don't want to have to babysit even the unit testing for this, right? That's where we do that for you, right? Because like you can even see in the code base like how I tested this is like I made sure that how it rendered the SQL using SQLite is exactly what you expect when it runs natively in DuckDB, Snowflake, Postgres, you name it. And you get to see this all open in the free in one place versus having to open 5 tabs if you're trying to understand dbt's implementation across like Databricks and others, or even if it has it, right? And so that's what I'm excited for you today. I think the biggest part of this is like, people like Tim and Randy and Alex in kind of like the data kind of open source community. This is something that resonates with them, and this is solving real problems for real people. And that's what matters to me, right? I don't care how cool or pretty my code is. I'm just glad that something that takes minutes of your time, that's boring and tedious, but not enough to like really complain because it sounds like you're a big baby. Now it's just like, oh, I just get to use this datespine macro and move on with my life. And it has error handling and it's in Python. So if I know Python, I can easily understand what's going on, because I know, for a fact that, maybe not for a fact, that's a big claim, but I know Jinja is really hard to test. And because of that, most people don't test it. And I did it. I barely tested my Jinja, even while working at DBT Labs, right? It's just because like Jinja is not a good framework to build like battle tested macros, right? And so I'm excited for how you guys use this. I'm excited for you to brag about how much time you don't have to spend doing boring, tedious things in your jobs anymore. And so that's why I built this. I'm excited for you to read kind of like the story written in my blog that kind of pairs with this. But overall, that's it. I hope you have fun with this. Oh, also, if you're like, hey, like I don't just want to eyeball this to copy and paste the code, don't worry, I got you, fam. I have this written in the docs. So when you look for this over here, you just get to copy and paste this example mindlessly. I designed it that intentionally, and then it'll render this as expected. In this case, you're seeing the DuckDB SQL rendering for this, but this will work, as you saw earlier, across any query engine that you really care about. But overall, like, I did this because it was a lot of fun, solves real problems for real people, and gives me an excuse to like connect with people I really admire. And so, yeah, that's it. See ya.